When y equals x minus 3 squared minus 5, the parabola has the same shape as y equals x plus 2. Pardon, x squared. It has the same shape because this parabola does not have a stretch factor and it's open upwards. The vertex is at 3, negative 5. So we'll place that point. We'll now go up. 1 squared is 1. So we go up. 2 squared is 4. 3 squared is 9. So we graph our parabola like so. We use these values because they're the same values as we would use if we were going to plot y equals x squared. Y equals x squared has the same shape. The first point is over 1, up 1. The next point is over another 1 and up 3. The next point is over 1 and up 5. And so on. We can check now. Is the y-intercept on the graph correct? According to the standard form, the y-intercept should be at plus 4. And it is located at plus 4. So we've done a good job of graphing. Graphing by completing the square. We'll try another example. We'll graph y equals 2x squared plus 12x plus 16. Our first step is to rewrite the equation in vertex form. To do so, we'll first remove the common factor 2 from the first two terms. 2 times x squared plus 6x. Now we'll complete the square. We need to add 9 to complete the square, but we also need to remove the 9 to make sure we're not changing the value of the expression. So we regroup things. We remove the negative 9 to outside of the brackets, and when we do so, we need to make sure we multiply it by 2, because when it was inside the brackets, it was being multiplied by 2. So now we have 2 times x plus 3 squared minus 18 plus 16, which is y equals 2 times x plus 3 squared minus 2. For y equals 2 times x plus 3 squared minus 2, the parabola has the same shape as y equals 2x, because it has the same stretch value. The direction of opening will be up. The vertex is at negative 3, negative 2. So we'll plot that here. Our next job is to figure out where our next 2 points are. 2 times 1 squared, because this is the same as y equals 2x squared, is 2. So we go over 1, up 2. Next we go over 2 and up 8. Over 3, up 18. And we now can draw the parabola. We can check by looking at the y-intercept. The plus 16 of the y-intercept cannot be determined on this graph. We'll now graph again by completing the square. Looking at example 3. We're going to graph y equals negative 0.2 x squared plus 2x minus 1. We'll first rewrite the equation in vertex form. Here it is in standard form. Y equals negative 0.2 times x squared minus 10x minus 1. So we've factored out negative 0.2. Now we must complete the square of these first two terms. The term we need to add is 25. So if we add it, we must also take it away. We regroup things. We remove the negative 25 from the brackets, and it becomes negative 0.2 times negative 25. This gets simplified to negative 0.2 times x minus 5 squared plus 5 minus 1. This gives us a final equation in vectored form of y equals negative 0.2 times x minus 5 squared plus 4. So, let's now sketch the parabola. The parabola has the same shape as y equals 0.2 x squared. So the direction of the opening will be down. The vertex is at 5, 4. We know it's going to be facing down because our a value is negative. We'll go over 1 and down 0.2 because 1 squared times 0.2 is 0.2. We'll go over 2 and down 0.8. We'll go over 3 and down 1.8. Over 4 and down to 3.2. So we're making these steps and completing our parabola. Here's what it looks like. We can do a check. Is the y-intercept on the graph correct? Our y-intercept should be negative 1, and on our graph, it is located there.